Welcome geometry students to another Regents review video for the Geometry Common Core Regents exam. My name is Trevor and I will be reviewing the June 2015 Geometry Common Core Regents exam. These will be the solutions for Part 1, questions 1 through 12. These are just smaller chunks, so you don't have the whole video to look at. So, without further ado, let's just talk about a few things before we begin here, and we'll start this exam. So, first and foremost, if you are here to copy answers, please refrain from doing so, because the Geometry Regents is really not easy. It's quite a difficult exam, so I want all of you to do well. So make sure that you were here to just really to learn and review the material in order to be successful on the Regents exam. And please visit my website at www.nysmathregentsprep.com. The link is in the description below, or you could just type it into a web browser. And without further ado, let's get started. This is the June 2015 Regents exam. So, question 1. Which object is formed when right triangle RST shown below is rotated around leg RS? So, I want to address a couple things when we do these questions in order to master this exam. Object means three-dimensional figure. Okay? So immediately, if it's an object and it's a three-dimensional figure, we could actually get rid of some answer choices. We could get rid of choice 2 and choice 3 because those are 2D figures. The trick answer for this case was a right triangle because the right triangle is shown. It's asking for an object that's rotated around leg RS. So when it says rotated around leg RS, we're looking right here. So your job is to continuously spin it around. So, well, what object do you get when you spin it around leg RS? Well, if you spin it, you should be getting a circular base, because if you spin anything, no matter how square it is or pointy it is, it's going to be creating a circular base. When you spin a triangle around one of its legs, it is going to create a cone. So the answer for number 1 is going to be choice 4, a cone. Moving on to the next question. Number 2, the vertices of triangle JKL have the coordinates 5, 1, -2, -3, and -4, 1. Under which transformation is the image triangle J prime K prime L prime not congruent to triangle JKL? Well, if we're looking for a transformation that is not congruent to the original figure, we're thinking of which of the following is not a rigid motion. And you need to remember what a rigid motion is. A rigid motion is a fancy term for a transformation that preserves distance and congruency. So you need to know that a rigid motion preserves distance and congruency. All right? So it keeps everything the same. So if we're looking at these answer choices, we're looking for the one, of course, that's not a rigid motion. A translation 2 units to the right and 2 units down. No, that's a rigid motion. That keeps everything the same. A counterclockwise rotation of 180 degrees about the origin. No, that keeps everything the same too. A rotation is a rigid motion. A reflection over the x-axis. No, that's also a rigid motion because reflections do keep everything the same. A dilation with a scale factor of 2 centered at the origin. That's your answer because a dilation changes the size of the image. All right, so a dilation changes size. Therefore, a dilation is not a rigid motion. All right, so that's question number 2. Moving on. The center of circle Q has the coordinates 3, -2. Stop right there. In geometry, when you're taking this exam, and I hope that your teacher told you this, when it says in circle, in quadrilateral, in whatever figure you're talking about, it's best to draw a picture just to see what's going on. So what I want to do is I want to draw myself a circle. And it says here that it has a center point of the circle, which is the coordinate 3, -2. If circle Q passes through point R, which is 7, 1, so it's passing through R. This up here is going to be point R, which is the point 7, 1. What is the length of its diameter? Well, we need to remember what we just drew here. That's a radius. A radius, by definition, is drawn from the center to the outside, well, not the outside, to the point on a circle. So it's 1/2 of the diameter. So we could find the distance of the radius because it's asking you for the length of the diameter. In order to find the length of the diameter, and we're only given the radius, we have to find the distance of the radius. When you're given 2 points, we could use the distance formula. And the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? Devote that to memory for sure. So now we are going to just plug in our coordinates. We're going to plug in 7, 1 and 3, negative 2. So plug in my x2, that's going to be 7. My x1 is 3. Square that. And we have 1 minus negative 2. Make sure that you start, if you start with one coordinate, you must start with the other for the y value. So the distance is equal to the square root. 7 minus 3 is going to be 4. Square it. 1 minus negative 2 is positive 3. Square it. And we get, let's see, 4 squared is 16. 3 squared is 9. And that's going to be the square root of 25. So the distance of the radius is 5. So that is the length of your radius. Now, to find the length of the diameter, we need to take the radius length and multiply it by 2, because a diameter is double the length of the radius. So your diameter is going to be 5 times 2, which is going to be choice 3, 10. All right, moving on to the next question, number 4. In the diagram below, congruent figures 1, 2, and 3 are drawn. Which sequence of transformations maps figure 1 onto figure 2, and then figure 2 onto figure 3? So in order to go from 1 to 2 first, it looks like it's being shifted up and over to the right. So that is definitely going to be a translation first. All right. Now for the second part of this, to go from figure 2 to figure 3, that looks like it's going to be a rotation. So we're looking for the answer translation followed by a rotation, and that is going to be choice 4. All right. This exam is pretty simple so far. All right. Number 5. All right. Real quick, before I go over this question, I use the TI Inspire CX calculator. It's one of the most powerful calculators to use for your math course, and I highly, highly recommend it. And there's a link on my website that allows you to purchase it off of Amazon. Now, make sure that your calculator, whatever calculator you're using, it has to be in degree mode. So go to settings on the TI Inspire, settings, document settings, and make sure that your angle is in degree. Okay? Click on make default. Click OK, and you're good to go. So now let's go back to the question and read it. As shown in the diagram below, the angle of elevation from a point on the ground to the top of the tree is 34 degrees. If the point is 20 feet from the base of the tree, what is the height of the tree to the nearest tenth of a foot? So what I like to do is I like to draw a little stick figure by the angle of elevation. And that, I mean, that could be me. Little red hair, ruggedly handsome, little smiley face, because I'm always smiling. Just kidding. Okay, so this is a classic example of SOHCAHTOA. All right, we have to use SOHCAHTOA to find the height of the tree, which is x, and this guy, which is me, little me, is 20 feet from the base of the tree. We use SOHCAHTOA when we're not given two sides of a right triangle. If we're given an angle and a side, we could use trigonometry. So we're forced to use SOHCAHTOA. Now, this angle right here, that's called your reference angle. So now you need to determine what are these two sides in reference to the reference angle. Well, side x is going to be your opposite side because it's across from that angle. And the side next to it is called your adjacent side. Adjacent means next to. So if we have an O and an A, we're using tangent. We're using TOA, tangent. So the form of this is going to be the tangent of some angle is equal to the opposite over the adjacent. Okay? Now the tangent of the angle that we're working with is 34. So the opposite is going to be x. Your adjacent is going to be 20. Now from here, what we do is we just simply cross multiply. Put the tan of 34 over 1, and we cross multiply. So we get 20 tan of 34 is equal to x. Now we just plug in that number into your calculator. So go to your calculator page, type in 20 tan of 34, and we get 13.49, which is going to be approximately equal to 13.5, which is going to be choice 3. All right, moving on to the next question. Number 6. Which figure can have the same cross-section as a sphere? You're looking for the figure that if we slice it anywhere, it's going to create the cross-section the same as a sphere. Well, remember that a sphere is just a fancy term for a ball. If you cut a ball up and down, side to side, on a diagonal, it's going to create a circular cross-section. So we're looking for one of these figures that has a circular cross-section, and the only one that works is going to be choice 2, because a circle can be sliced out of a cone just like so. All right, that's number 6. Number 7, a shipping container is in the shape of a right rectangular prism with the length of 12, a width of 8.5, and a height of 4. The container is completely filled with contents that weigh on average 0.25 pounds per cubic foot. What is the weight in pounds of the contents of the container? So, a right rectangular prism is just a fancy term for a box. A box. All right? And we're trying to find the weight of this box. You need to know the formula. Weight is equal to density times volume. Weight is equal to density times the volume. So if you know that information, we could calculate the weight. Well, we already know the density. The density of this box is 0.25 pounds per cubic foot. That's your density. Now we just have to find the volume. Well, what's the volume formula of a box? Well, volume is equal to length times width times height. Pretty simple. So the volume of this box is going to be the length of 12, a width of 8.5, and a height of 4. Let's go ahead and plug that into our calculator. So we get 12 times 8.5 times 4. That's going to be 408. So we get 408. Now, we take this piece of information, we take 408 and the 0.25 pounds, and we plug it into our weight formula. So once again, weight is equal to density times volume. The density is 0.25, and we are going to multiply by 408. And your weight is going to be 102 pounds, which is going to be choice 3. Number 8. In the diagram of circle A shown below, chords C, D, and EF intersect at G, and chords CE and FD are drawn. Which statement is not always true? Not always true. Okay, so we need to know a couple things in order to get this question right. First and foremost, triangle ECG is similar to triangle DFG. How? By angle. These two triangles are similar by angle for the following reasons. 1, vertical angles are congruent. So we know for sure that the vertical angles are congruent. But we need another angle to prove these two triangles similar. Now, these two triangles are similar because this angle and this angle are inscribed. Now, inscribed angles are 1/2 the arc it intercepts. So notice here, ladies and gents, that they both intersect the same exact arc. They intersect arc CF. If you have two inscribed angles that intersect the same arc, those two angles are congruent. So that's another theorem that you should know. Two inscribed angles that intercept the same arc are congruent. Now, why am I telling you this? I'm not saying this for no reason. Because the answer choices require your knowledge of similar triangles. If we take a look at the one that's not always true, choice 1 says that CG is congruent to FG. Is that true? No, it's not. That's an assumption. And these two triangles are not congruent, so that is the answer. Choices 2, 3, and 4 all show similarity. Choice 2 says the measure of angle CEG is congruent to FDG. But we just proved that based off of this theorem over here. If two inscribed angles are in a circle that intercept the same arc, they are congruent. So that's true. Choice 3 shows proportionality. Similar triangles are in proportion, so that's true. And last but not least, choice 4 says that they're similar. Yeah, they're similar by angle. All right, so that was kind of a tricky question, and you have to know your circle theorems in order to get that question right. Number 9, which equation represents a line that is perpendicular to the line represented by 2x minus y equals 7? So you need to know first and foremost that perpendicular lines have negative reciprocal slopes. That's the key to get this question right. Reciprocal slopes. All right. And also, perpendicular lines form right angles. So if we have this equation, which is 2x minus y equals 7, your goal first is to calculate the slope. Well, in order to calculate the slope, put this in y equals mx plus b form. In order to begin that process, what we're going to do is we're going to move that 2x over. So we get negative y is equal to negative 2x plus 7. Okay, divide by that negative 1 because we want y, not negative y. Those negative 1's cancel. We get y is equal to positive 2x minus 7. Now, what does this tell us? Well, we just found the slope of the original line, but we're not done yet. Your job now is to calculate the slope of the new line, the line that's perpendicular to this line here. So, in order to calculate that slope, you need to take the slope of 2 and take the negative reciprocal, which is going to be, you flip the fraction, so 2 becomes 1/2, and you change the sign. 2 is positive, so in this case, your slope is going to be negative 1/2. So if we go back to our answer choices, the only one that works is going to be choice 1, because choice 1 has the slope of negative 1/2. All right, number 10. Which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? You need to know a formula to get this right. So, the formula that you need to know is 360 degrees divided by the angle measure that's given is equal to the number of sides. So, it's saying which regular polygon has a minimum rotation of 45 degrees. Well, take 360 degrees, divide that by 45 degrees, and you get your number of sides. 360 divided by 45, that's going to be 8. The only figure that has 8 sides is going to be an octagon, so that will be choice 1. Number 11. In the diagram of triangle ADC below, EB is parallel to DC, AE is 9, ED is 5, and AB is 9.2. Now I want to make this clear. The Geometry Regents likes to throw this garbage in. EB is parallel to DC, but what does that mean? Well, if you know that the lines are parallel and they're cut by a transversal, I know personally that angle D is congruent to angle AEB. And angle A is reflexive in this small triangle and the big triangle. So we can conclude that triangle AEB is similar to triangle ADC by angle. And that's important because now we could set these two triangles in proportion to solve for the length of AC, which is going to be your x value. Now, it's saying what's the length of AC to the nearest tenth. What you need to do is you need to set these two triangles in proportion to each other. The problem is, how do we do it? Well, the first thing that you need to do is add up 9 and 5 to get 14, and I'll tell you why. Because I want to set the 9 in proportion to the 14, and then take my 9.2 and set it in proportion to my entire length of x. What a common mistake that people do is they do 9 over 5 equals 9.2 over x, and then they stop here. But you have to read the question thoroughly. It's saying the length of AC. Now, could you do it like that? Of course you can. I'm going to show you 2 ways. By the way, there are so many ways to answer these questions correctly. So the first thing that I'm going to do is I'm going to do it my way that I like. I do 9 over 14 is equal to 9.2 over x. You just cross multiply right now. So we take 9x and we get 128.8. Divide that by 9. And we get x is equal to 14.3. And that is your answer. It's going to be choice 3. But if you like to do it this way, where you call BC y, you could set this in proportion by doing 9 over 5 is equal to 9.2 over y. Then we get 9y is equal to 46. Then we divide by 9 on both sides, and then we get y is equal to 5.1. But the only problem is, ladies and gentlemen, that you have to remember to add the 9.2 and the 5.1 to get your answer of 14.3. So that's how you do question number 11. And last but not least, number 12. In scaling triangle ABC, shown below, the measure of angle C is 90 degrees. Which equation is always true? Okay, this is a type of question that your geometry teacher should have by now drilled into your brain. And that answer is the sine of A is equal to the cosine of B. And let me show you why. Let's take the sine of A. The sine of A is equal to the opposite over the hypotenuse, and that is derived from SOHCAHTOA, because sine is equal to the opposite over the hypotenuse. Now, if I draw my little stick figure up here, your opposite side is side CB, and your hypotenuse, which is always across from your right angle, is AB. So we have CB over AB. Now, the problem is, what is going to be the cosine of B? That's what we have to figure out. Well, the cosine of B should be equal to the sine of A, by definition. Now, the cosine of B is equal to the adjacent over the hypotenuse. All right? So the adjacent side is CB, and the hypotenuse, which is, again, across from the right angle, is side AB. And look at that, folks. CB over AB, CB over AB. So the sine of A is equal to the cosine of B. So that's going to be choice 4. And that is the conclusion of the first part of this exam. Please subscribe to my YouTube channel. There are so many more videos on this channel to help you with math preparation. And make sure that you visit my website at www.nysmathregentsprep.com. And I'll see you soon.